Okay, we're back. This time we're going to go through section 4 of option B. This is over lipids. I'm going to go pretty quickly here. There are 3 types of liquids found in the body. There's only one there's 2 I'm going to somewhat talk about. Unfortunately, I don't have the capability of drawing them very well here, so you're going to have to do a little bit of work, a little footwork, looking some things up. But they are, in no particular order, triglycerides, which form most of the fats we are used to seeing, fats and oils specifically. There are phospholipids. Most commonly, you would consider them to be the parts of the cell membrane, of course, and steroids. Steroids are precursors for many things: hormones, sex hormones, growth hormones. They are precursors to cholesterol and many compounds in that nature. So I'll refer to them briefly. I'm going to focus most of my time on triglycerides and fatty acids. I will say this, that in triglycerides, they are formed from a molecule called glycerol, which is, think of that as a trihydroxyl alcohol. So there's 1, 2, 3 glycerol, and you get this will typically react with 3 fatty acids. Now, fatty acids are carboxylic acid. The term fatty refers to the fact that they have lots of carbons over here. And so you have to understand kind of the system here. And a lot of times they're symbolized like this in that crooked structure. Each of these branches represents a carbon. And if you don't see any double bonds like this, that means that they all have single bonds. This would be called saturated. This would be a saturated fatty acid. So you have to imagine that you remove H2O, and so what you would replace in each of these cases, let me clean this up a little bit. You have to imagine all the water's leaving. So what you'd have is one of those oxygens remaining. This is an ester. If you see the double bonded O to another carbon group, these are ester linkages. So what you have here is a fatty acid connected to the glycerol molecule. This is a saturated fatty acid with no double bonds. You could also write this, this C double bonded O part would be that, and then you'd have 1, 2, 3, 4, 5, 6, 7. And then a CH3 on the end. So that's like a condensed structural formula for this. Sometimes you have double bonds. So that would be a a double bond. Excuse me, my symbolism here is a little messed up, isn't it? Let me clean this up slightly for us. Maybe a carbon there. Okay. The double bond here, a single double bond, will be mono unsaturated. Please remember that this carbon and this carbon only have 1 hydrogen attached, not 2, so this condensed structural formula would change. Little side note, if you see this term, notice how the carbon branch in both cases comes off the same side, both downward. If it's the same, that's called cis. If you ever see that phrase cis, that's what it's referring to. If you ever see a double bond that has the branches, so here would be the H's, for example, and this could be other carbons as part of the fatty acid. This would be called trans. So the phrase trans fats refers to that. So that's something to keep in mind. So I'll just put a more conventional straight thing. So this is a triglyceride. Now, triglycerides can be either solid or liquid. The solids would be fats. They're more likely to be solid or called fats when these fatty acid portions have very few, if any, double bonds. So mostly saturated fats. Those are these solid ones. There might be 1 or 2 double bonds here and it would still be solid. But the more double bonds you have here, the more likely it is a liquid at room temperature because they can't pack as tightly. It decreases the surface area of contact, so the van der Waals forces are fairly low, and they are oils at room temperature. I'm going to ask you on your own to look up phospholipids. I will attempt to draw a steroid. It's really difficult. from memory, to be honest with you. But it is important that you understand that they are mostly carbons and hydrogens, as most fats are, which allows for very dense energy storage. I guess I could talk about that now. Fats are very efficient in energy storage because they have very few oxygens in this portion. An oxygen molecule has a higher electronegativity, so it pulls electrons toward it. And if you've studied biochem at all, if you remember, think of the electron transport chain. That process takes electrons from one energy state and releases them to reach a lower energy state, and it harnesses some of the work or the energy released in that process. Well, because of the high electronegativity of oxygen, the presence of it tends to mean there's less usable or harnessable energy. It's more difficult to remove it from oxygen. Oxygen tends to be a final destination. For example, the electrons in the electron transport chain end up bonding to an oxygen molecule and picking up some hydrogens that go through the wall of the mitochondria to form water. That's why we urinate water. It's a waste product for us. So fewer oxygens means there's more dense energy storage. And steroids are no exception. They have not a lot of oxygens. They do have a backbone which looks something like this. It's a four-member ring. It's not actually important that you draw it. You will see this in your data book. But I do want you to see it. I'm not a very good artist, excuse me. So there's the third one, and the fourth one is a furanose ring. You don't even know what that means. Right there, five-member ring is what that means. So this is a steroid backbone. So for the steroids you're going to see, and you're actually going to be required to read them if you have the time to do such. This is the backbone, and there will be various functional groups attached, and that is the difference in function. One of the points you are required to know states, let me find out which one that is, so you can look it up on your own. That would be, oh, it looks like that's one of the hormone issues. So if you look in B.6.2, it asks you to differentiate between cholesterol and the sex hormones, and they both share this backbone, but there are various subgroups attached that give it different properties. For example, there may be some OH groups attached which give it more solubility in water. There may be some longer fatty groups, and those attachments typically they play an important role in either being carried through the bloodstream or through the endocrine system, and they also play roles in, for example, entry into cells. They may be chemical messenger signals and things of that nature. So I'm going to let you read that on your own. I'm just going to focus on basic lipids, fatty acids, and triglycerides. So one of the points you do need to know is the difference between HDL and LDL. I'll let you, the structure difference is not typically important, but HDL, this is typically called good cholesterol, plays a role to sequester cholesterol. So cholesterol in the blood is required. It's important for good brain function because your brain is a very fatty organ. And there's cholesterol. It serves quite a few purposes in your body. However, too much of it in the arteries, and it can basically link together. It forms sludge, and the sludge can kind of hook up and form clots in your arteries. It can block blood vessels. It's pretty dangerous. So high levels of HDL signify that the cholesterol is being removed, excess is being removed and sequestered, typically in the liver. So that's what that is. LDL, is typically called bad, even though some of it is required. It helps to maintain solubility of cholesterol, so it keeps it in the blood, keeps it circulating. So they somewhat opposite in function, and you can read on your own for some of that, but just be aware that there is a difference between the two. We've already talked about the difference in structure between saturated and unsaturated. Remember, this is unsaturated. Let's see, the next one, you're being asked to tell the difference between linoleic and linolenic. Now I'm not going to draw them because they're actually in your data book. and you can draw them for you. Linoleic is known as omega-6, and linolenic is known as omega-3. They play a role in nervous system function, among other things. So it's one of those things, if you want an extra mark here and there,